we try to really learn about something about the scalars, vectors, tensor, and we are going to continue in that line further, trying to learn something like a special operator named Kronecker delta. It is more like your identity matrix. So for example, here I'm showing something like delta 1 0 0 0 1 0 0 0 1 in 3 dimensions. Can you see that? This one. This is what you call Kronecker delta in this indicial notation. And typically the representation will be delta ij. This is a tensor of rank 2. And if I is equal to j, then it has a value 1. If I is not equal to j, then it has a value of 0. It's more like identity matrix for your case. And it is very convenient to switch from one vector to other vector. The directions and so on, so kind of stuff, we can be really going to change. We will look at that example, then we will see what it means. For example, let us look at a tensor of rank 1 or a vector and a tensor of rank 2 delta. Now, what will be the condensation between this Kronecker delta and a vector? So delta dot a. If I would like to really look at in indicial notation, delta ij, if there is no product, inner product, delta ij may be ak, I would have written. But because I would like to condense it, one of the index, I would like to really repeat it in a loop. That means if I am going to have this dot thing, j becomes k in the loop. So delta ij aj it becomes. Same thing I can always condense even in terms of I and k also. In that case, my delta ij ai also it becomes. It's just a loop. So in that loop, the free index here j, here the free index is I. So for I is equal to 1, 2, 3, for j is equal to 1, 2, 3, how summation really happens and what is that leftover index? That is the way we calculate delta in terms of ij's and so on. So let us look at that example. If I have this delta ij ai, summation delta ij ai, which gives me only aj vector, because everything is 1 0 0 0 1 0 0 0 1. So I will be having a1, a2, a3. What I am going to get? a1, a2, a3. So the whole property of Kronecker delta is more like your identity matrix. If you condense it, then only you will be going to get aj. If you are not going to condense it, you would like to really get a free product, Tij or delta ij. Ak you would like to have product, then 1 multiplied by a1, then 1 multiplied by a2, 1 multiplied by a3, then 0 multiplied by a1 and so on. You are going to increase the index of this entire tensor. So it's all depends on how you would like to really play with this Kronecker delta. That is one of the important relation one should really know for this tensors. One is the permutation symbol, other one is this Kronecker delta. So that one I try to really explain it in terms of matrix notation. Delta ij ai gives me aj is delta 1 1 multiplied by a1, delta 2 1 a2 and so on so stuff. This is delta 1 1, delta 1 2 by keeping I constant, delta 1 3, delta 2 1, delta 2 2, delta 2 3 and so on. We write it in that way. Okay, great. Now there is an important relation for this Kronecker delta and permutation symbol. This math one has to really practice it, then only one will be in a position to get comfortness. So there is an important relation. If we have something like a permutation symbol epsilon ijk and epsilon ilm, these two things multiply. If you are going to do that, one will get only in terms of Kronecker deltas. Delta jk, delta lm minus delta jl, delta km. We are not proving, but this important result we require it. So you must have remembered permutation symbol means when I, j, k goes in a cyclic way, it has a +1 value. When I, j, k, any clockwise kind of thing is broken down, that will be having -1 value. If any of the I becomes j or j becomes k, then that value is equal to 0. That is permutation symbol. Where delta I is more like your identity matrix. When I is equal to j, you will be having 1. When I is not equal to j, you will be having 0. So when these two things are going to multiply, epsilon ijk, epsilon ilm, then we will be having a special combination of Kronecker delta, delta jk, delta ilm minus delta jl, delta km we will get. So the way how you will really remember this relation without proof, when such kind of epsilons are multiplied, where one of the index is repeating, that means there is something like summation naturally comes. Further purpose, what you have to do is write 4 deltas. The first step. I'm just giving more like a recipe. Put minus sign in between 2 of these deltas. Then use what are these free indices at any of this epsilon. Here I is repeating, so that cannot be free index. That is participation under summation. The free indices are here jk and here lm. So you pick those things, write in the first delta jk and second delta lm. For the other deltas, what you have to do is pick j and pick l, write it jl here. Similarly, pick k, pick m, write it here. This is the way people remember this epsilon ijk, epsilon ilm relation in terms of Kronecker deltas. This becomes one of the most important relation when we are going to simplify the thing during our course, whenever vectors are coming. So let me re-look at that step. Okay. So epsilon ijk, epsilon ilm. If I would like to write 4 deltas, I have to write. Then in between 2 of the deltas minus sign. Whatever jk comes here, whatever lm comes here, and jl, the other indices jl and other indices km, we will write it. Now let us look at one of the application why such kind of things becomes important. For example, let us look at these 2 vectors. Can you see a cross b dot c cross d? Hello.
Yes, sir.
Okay. Now I would like to verify this relation. Why we are verifying this? We are learning this math so that when we are going to play with our velocity fields, stress fields, and so on, so kind of stuff, maybe this kind of cross product, dot products of higher rank tensors we may be ending up with. Further purpose, we are practicing first of all simple this vectorial calculus. So A cross B dotting with C cross D. And we would like to show that as A dot C multiplied by B dot D minus A dot D multiplied by B dot C. How do you show that at your +2 level? If this kind of relation I would like to show. Can one of you really tell me? Before really jumping into how easy this tensorial notation or indicial notation. Can you tell me, guys? If I would like to really show this kind of relation, because maybe in fluid mechanics, we may be going to end up with this kind of vectors, dot product, and so on. We would like to really sense a very simplified result. In that case, we may require such kind of relation to be proved. Then how will you go with your +2 kind of mass? A cross B dotting with C cross D.
Sir, it can be a box product and then we can break it like that.
Okay, see how easy it will be once we learn this indicial notation. Let us look at what is A cross B. A cross B in terms of indicial notation is epsilon ijk ai bj, because A vector ai, B is a vector bj, and cross product will be replaced by epsilon ijk, where j and I are indices coming from A vector and B vector, so that the cross product always gives you a new vector in the perpendicular direction. The perpendicular direction might be k. So epsilon ijk ai bj is a new vector resultant of A cross B, and this one is Gibbs notation, and this is indicial notation. If you can really think of like last day class computational way, then there is a repeated index in terms of I and j's, so that only leftover index will be k. Now let us look at C cross D. A new vector in a new loop you are going to write in the program. So you are writing it in a new loop or new program kind of thing. C cross D is equal to a vector Cn dp multiplied by epsilon mnp. It may not be necessary in the same loop. Ijk information may be there, it may not be there. So what we would like to really have is, again, I'm going to write a new loop for m is equal to 1 to 3, for n is equal to 1 to 3, for p is equal to 1 to 3, condense Cn and dp, so that I will be going to end up with only vector of m in the loop. M also varies from 1 to 3. I also k also varies from 1 to 3. It doesn't matter. Now, what is A cross B dotting with C cross D? That means I need to do these two vectors. After that, I would like to really condense one of the index. So that means A cross B is epsilon ijk multiplied by ai bj. I need to condense dot epsilon mnp cn dp. Is there a problem in terms of this notation up to this part? Is this clear? Hello? Is there a person who had difficulty in terms of writing this notation? Okay, fine. There is no issue. So epsilon ijk we already know, having +1, -1, 0 kind of things. Epsilon mnp also having +1, -1, zeros based on the notation. Now, condensation I would like to really do. What are these condensation variables? We have to really see. Already np, cn, dp are condensed. Only free index is m here. Already ij are condensed. So the free index is k. So the condensation is only possible in a loop on k is equal to m. So we are going to condense on k is equal to m. That means either k I will replace it by m, or m I will replace it by k. It doesn't matter. And each of these variables are scalars in this computation. You think of your computer program where you are handling only components of those vectors or tensors or whatever which we call scalars. Tij or aj, ai, we handle only scalars. That means when I am condensing that, k I can replace by m, k I'm going to replace by k for m also, because these are scalar multiplications. Epsilon k np I can bring it to next to each other, and ai bj cn dp. This is also your scalar multiplication. Is this step clear? Hello, is there a person it's not clear? Okay, fine. So epsilon ijk, epsilon knp, ai bj cn dp. Now what is the value of epsilon 123, epsilon 231, epsilon 312? Because of cyclic notation, this is also +1, this is also +1, this is also +1. So epsilon ijk, epsilon knp, I am going to bring k followed by I followed by j. So this one can be rewritten in terms of epsilon kij. Now epsilon knp as it is, I'm going to leave epsilon knp. The remaining things ai bj cn dp. Now already we have learned this relation. Epsilon something like kij knp can be replaced. Whatever four deltas we have, delta, 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 delta with minus sign. Here k is summation, free indices are ij and np. So ij, np, I, n. So I, n. Second thing, j, p. So jp. So I can always write this entire epsilon kij, epsilon knp as delta ij, delta np minus delta in, delta jp multiplied by ai bj cn dp. Now it is just an algebraic summation. So separate out ai bj cn dp, multiply with this entire algebraic relation, which is delta ij, delta np, ai bj cn dp minus delta in, delta jp, ai bj cn dp. Is scalar multiplication, delta ij, delta np, ai bj cn dp, delta in parenthesis delta jp, ai bj cn dp is just a associative rule in terms of product for scalars. Now what exactly delta np multiplied by ai bj cn dp is scalar? So ai bj comes naturally from delta np multiplied cn dp is a Kronecker delta. Delta np cn is cp. Is this step clear? Anything like delta ij of a particular vector ai gives me aj. That means delta np cn supposed to give me cp vector. That property what we have used at this first step. Is this clear? Hello guys. And this becomes very important. If it is not clear, this is the right time to ask me. So delta np multiplied by cn is cp and dp as it is. Delta jp and maybe where is bj? So that becomes a bp. So delta delta ij ai bj cp dp minus delta in ai bp cn dp. Now still there is one delta ij ai bj is there. So delta ij acting on ai. It can act on any of these because it's just a scalar. I can even do it on bj also. So delta ij ai is aj, bj as it is, cp as it is, dp as it is, minus delta in acts on ai, so an, bp as it is, cn, dp as it is. Now aj, bj, cp, dp. By computational programming, aj, bj means already we have condensed in between vectors, that is a dot b, parenthesis cp, dp, which is c dot d, an, bp, cn, dp, because it's scalars. An, cn is a dot c, parenthesis bp, dp, which is b dot d. So which is your a cross b dot c cross d is a dot c, b dot d minus a dot d multiplied by b dot c. This is the way one will be going to simplify the things. Sometimes when we are going to handle the problems, there will be vectors which are perpendicular to each other, multiplied and so on, so kind of stuff. We would like to really simplify it in terms of scalars. So the easiest simplification what we will be in a position to really see is such kind of a dot c, b dot d minus a dot d, b dot c. If it is something like we have to really remember this formula, it may not be possible. Please understand this issue. When we are going to have this, if I am asking you to remember this formula, it may not be easy. There will be hundreds of formulas. We cannot really remember. But if we remember only this basic information like Kronecker delta, permutation symbol, writing indicial notation, it becomes so easy to really come to this. We don't really have to remember any other extra information other than these loops, how these loops are going to simplify. That kind of general formalism what we have learned. Is this fine, guys? My suggestion, please, each and every individual, it might look a bit difficult at this starting stage. It's more like learning a bicycle. When you start learning a bicycle, you start feeling on the first day, when you are not having any exposure, you start feeling like that is your last day. You might fall, you might die, but that's not the point. It takes a little while to get grip. So what I would suggest is, look at the notes, again go through that notes, what I have explained, follow this video recording also, try to sense how much you really understood, practice it. Once those steps are clear, it's just matter of how much time it really takes for you to practice it. Fine. Now let us think of one simple example. There is something like a divergence operator or gradient operator, delta. Are you familiar with this operator delta? Hello, is there a person who is not comfortable? Hello, are you aware of this operator? Gradient, Napla.
Yes, sir.
Is there any person who is not familiar with this operator? Okay, wonderful. So what is this delta dot u? That we would like to really see. So in the initial notation, divergence operator is delta I. U is uj. But because of dot, I would like to condense I is equal to z. That means either replace I by j or j by I in the loop. So which is delta I ui. All are scalars here. Which is, if I am going to replace gradient, del by del xi ui. By Einstein summation, when I have I is equal to I, here summation I is equal to 1 to 3 del ui by del xi is just a notation. Rather than really remembering this entire formula, writing it, usually at textbook levels, fluid mechanics, solid mechanics, this kind of courses, what we write is del dot u means del ui by del xi, shorthand notation. Because of repetition of indices, it is think of as summation I is equal to 1 to 3 del ui by del xi. That means I varies from 1 to 3 del u1 by del x1 plus del u2 by del x2 plus del u3 by del x3. Okay, fine. Let us look at one more example. Del cross u epsilon ijk del j uk. This is the way cross product is defined. One can also write y ijk del j uk. I can always write epsilon ijk del I uj also I can write, so that the free vector will be k here. Here the free vector will be I. It's just index is varying, whether I is equal to 1 to 3 or k is equal to 1 to 3. That's the only thing. So epsilon ijk del j uk is del uk by del xj. That is the thing what we are writing here. Epsilon ijk del uk by del xj. Now already we know permutation symbol. When I, j, k things becomes one and the same, their values will be 0. When their values are not equal, you have either +1 or -1. So let us fix free index I is equal to 1. That means any j is equal to 1, k is equal to 1, j is equal to 2, k is equal to 2, this kind of things left over. So what we will ending up with, when I is equal to 1, we are going to fix it. The first component, j is equal to 2, k is equal to 2 survives, or j is equal to 3, k is equal to 2 survives. These are the only possibilities what it really survives. That means epsilon ijk del uk by del xj is del u3 by del x2 multiplied by +1, del u2 by del x3 multiplied by -1. This is the only combination survives. Similarly, when I is equal to 2, the only combinations of k and j survives is j is equal to 3 and k is equal to 1, or j is equal to 1, k is equal to 3. Only these two combinations survives. Now I is equal to 2, 3, 1, 2, 1, 3. So +1 minus combination. So j is equal to 3 and k is equal to 1 component. Similarly, j is equal to 2 and k is equal to 3 components survives. Similarly, when I is equal to 3, we will have components which survives is j is equal to 2, k is equal to 1, and j is equal to 1, k is equal to 2. These are the only components survives. If I write it, it becomes like your typical vectorial product, del u3 by del x2 minus del u2 by del x3, and so on combinations. Now, okay, anyway, it's 10 o'clock. So we will catch up in tomorrow's session to begin with u dot del u terms and also what is Gauss divergence theorem and Stokes theorem. With that, we can close our math session. Okay.